Welcome back to another chapter in the Advanced Project Management Certification. Once again, I am your host, Ibby Taylor. And in this one, we're going to be looking at schedule management. Now, schedule is not just about when things happen. It's more about the whys and the hows. So it says here, imagine coordinating an orchestra where each musician plays at precisely the right time to produce a harmonious symphony. Project schedule management is the conductor's baton in the world of project management. It ensures that every activity, task and milestone occurs at the right moment. Scheduling isn't just about the dates and times, it's about orchestrating efficiency, reducing risks and guiding a project to success within its constraints. So it's all about understanding the clear picture and understanding when things need to happen, but why they need to happen in that manner. What's the benefit? What's the reason? Let's look at some key points. Scheduling processes form the backbone of project timeline management. They follow a systematic flow as outlined, of course, in the PMBOK. Now, define activities. Break down project deliverables into smaller, actionable steps. While constructing a building, activities could include laying the foundation, erecting walls, installing electrical wiring. So the tools is decomposition techniques and work breakdown structures. Sequence activities. Determine the order tasks need to occur based on the dependencies. Finish to start, start to start, etc. In that example they just gave us, laying the foundations comes first. Without that, erecting the walls can't happen. So in your schedule, you're going to have laying foundation first, you're going to have erecting the walls second, and the why behind that is because one is dependent on the other. So installing wiring can't happen before the walls are erected. Okay, it had its own example, which I didn't see, and I used the other one. But exactly the same principles there. So dependency mapping and precedence diagrams. What is dependent on the other? Estimate activity durations. Use historical data and expert judgment to approximate the time required for each task. For example, when it comes to building the house, we have a good idea now, because so many houses have been made, how long it takes to dig the foundations, how long it takes to put walls up, to install wiring, to plaster over it. You can then use that within your schedule. You've got your dependencies, you know what needs to happen, in what order. You then build in the time estimates, and then you've got an idea of how many days, of what sort of timeline you're going to be running to. Example there we go. Digging a foundation may take 3 days with optimal resources. Past projects in similar environments provide benchmarks. Analogous estimation, parametric estimation and 3-point estimation are tools that you can use. Develop a schedule. Combine the work activities, sequences and time estimates into a cohesive timeline. It's almost like I've read this before. But no, these are things that these happen as standard. When you're planning your schedule, you bring in everything that you know to be true from things that you've done before. What we know to be true is that the foundations have to go first. We can know roughly how long that job will take. Now there are times where we're doing jobs that we haven't done before and estimations have to be made. We'll touch on that in just a few slides time. So you can use a Gantt chart to visualize durations, dependencies and progress, and that will map your project from start to finish. Gantt tools, CPM and PERT, we'll touch on that in just a little while. You won't know what that acronym is just yet. Control schedule, so monitor project progress, track the deviations and implement corrective actions. A mid-project review identifies delays in equipment procurement, leading to resource reallocation. It does happen. Earned value management, EVM, can be used for that. So key scheduling tools. On this one you will see the PERT chart, which obviously we picked up on the last slide. This is what's going to outline what that is. So the critical path is a method that you can use. So this identifies the longest path of dependent activities and then the minimum time frame for project completion, because you're going to have things that are dependent on the thing before it. For example, the foundations. You can then erect the walls. Once the walls are done, you can do the cabling. But there are going to be things that kind of come off that branch, that come off the critical path. Once the plastering is done, you can then get the internal fitters in. You can also get the electricians in. You can also get the decorators in. You can get the flooring people in. But they aren't on the critical path. The critical path is determined by the things that are dependent on one another. So the foundations, the walls, the roof, It's those critical things that exist in a path connected to each other by dependencies. Now you also have program evaluation review techniques, PERT, there is a chart there. So it's a probabilistic tool, which means it's based on probability. And it uses 3 estimates: optimistic, pessimistic, and most likely, to calculate timeframes where uncertainty exists. If we don't know exactly how long something is going to take, if we've never laid foundations of this scale before, we can look at 3 estimates. Optimistic, yeah, we can do that in 2 days. Pessimistic, that's going to take 8 days. Might take 8 days, could be a long one, we don't know. And then most likely is normally roundabout in between the two. So most likely there is probably, most likely is about 6 days. Not too quick, not too slow, but it could be anywhere within that range. And you can calculate timeframes where uncertainty exists, and you can give a best case, a worst case, and a most likely average outcome, really. So Gantt charts then combine visuals with dependencies, and they're perfect for tracking progress and identifying bottlenecks. Now, schedule compression. Techniques like crashing and fast tracking can reduce project timelines without compromising quality. So when you've got things that aren't on the critical path, can you fast track? Can you bring something around? Can you do things at the same time? Can you, bring in more resource to fast track something? And resource leveling. Adjust resource usage to prevent over-allocation. It's about looking at the resource that you have available and looking at what percentage of their time you are taking. This is prevalent especially in things like software development. You assign tasks, you work out what your tasks are, and a rough idea of time. So, okay, I've got this task, this is 2 hours. I've got 4 of these tasks, I'm going to give them all to person A, all on one day, and then someone else gives them more tasks. All of a sudden, they've got 10 hours of work, but they only work an 8-hour day. They're over-allocated. So you then need to look, right, okay, I need to take 2 hours off this person. I need to move around the tasks in order to make sure that someone doesn't have more than they're physically, humanly capable of in any given day. So advanced considerations. Resource dependencies. Scheduling often hinges on resource availability. Incorporating human and technical resource calendars ensures feasibility. So risks and contingencies. Every schedule should build in buffer time and contingency plans to accommodate unforeseen risks, because they always happen. You always need that extra contingency time. You always need that extra buffer. Shipping delays for materials might require a buffer in construction projects. Exactly right. And that is something that is typically outside the control of a project manager. But a good project manager is aware of those risks, has done their risk planning, and knows that they might need a buffer in place to deal with these uncertainties. And then integration with other plans. Obviously, we've touched on integration already. A schedule doesn't exist in isolation. It's closely tied to the scope, cost, and quality plans. And as the scope changes, the cost, the budget changes, and the quality plans change, the schedule is going to change too, because it has to. Because you can't deliver, for example, if your scope changes and it increases by 20%, you can't then keep the schedule the same. If you do keep the schedule the same, you're still going to need to change the schedule because you're going to need more resource, or you're going to need to very cleverly plan your activities in order to do it in a manner which allows you to deal with that change control. So the schedule is tied in and acts reactively to everything else that's changing in the project. Obviously, software like Microsoft Project, of course, Primavera P6 and Smartsheet provide advanced capabilities for timeline visualization, task assignment, and process tracking. There's also loads of others. You've got ConnectWise, you've got Trello, you've got Asana, you've got many different things that can be used. Applications, again, as always, I'm not going to run through all of these. But when you go through these, give some thought to the scheduling elements. So constructing a skyscraper, process used activity sequencing and resource leveling using Gantt chart and CPM. Reduce delays through optimized resource usage. There's going to be a lot of sequencing when you're constructing a skyscraper, naturally, because there's going to be a lot of dependencies in there. Foundations need to go in. Even in laying the foundations, that in itself is a project where the hole needs to be dug, it needs to be confirmed as good, it needs to be safeguarded. The concrete then needs to be poured, the piles then need to go in. These are things that are then dependent within each other. And then on the wider scheme of the building as a whole, the foundations are its own element, which other things are then dependent on that. So a lot of activity sequencing, and obviously resource leveling to understand, what resource you have available. Right, okay, I have 50 builders that are all working 8-hour days, therefore I've got 400 hours, man hours, to play with each and every day. But on this day, on a Wednesday, I've got 900 hours of tasks to be done. That's not going to work. Or, someone's got an 8-hour day and you've got 14 hours worth of tasks on them. Again, that's just not physically possible and feasible. So you need to level that resource. You need to ensure that no one is overburdened so that you are capable of sticking to schedule. Because if you don't, someone's going to work an 8-hour day, still have 4 hours of tasks, and they might have an 8-hour day the next day, and it's just going to keep pushing things up and leading to further delays down the line. So have a little look through these examples here and give some thought to the scheduling and the scheduling points that were used and what benefit they had to the project. Once you've got through these, of course, you've got the summary tables. Have a look through and confirm your understanding of scheduling. And then after that, as always, you've got your practice questions. Give these a go and see how you do. If you do struggle, come back and watch this again, or read through the guide and study materials again. Challenge your own understanding, but if you do still struggle, as I always say, reach out to us. We are here to help, and we are here to mentor and guide you through to success. So thank you very much. This has been Schedule Management. I've been Ibby Taylor, and as always, I'll see you on the next one.